Welcome to the Product Design and Development. This video is part of a series of videos that collectively cover Product Design and Development course. So please make sure to check out the rest of the videos in this series. This video covers the minor differences within product development processes based on different product types. In a previous video, we covered the generic product development process or mechanical design process. And I used 4 keywords to remember the 4 main phases. Phase 1 was planning, involved project, put together the project plan, very simplified version and brief description of it. Part 2 was specifications, when you turn your customer requirements into engineering specification and design targets. So we just called it the specs for short. Step 3 was conceptual design or just design phase, conceptual phase. And then step 4 was product development, or as the keyword that we used was make it or build it. The product. So these are the 4 main phases. But again, depending on the type of product that you might have, this process might be tweaked a little bit. Some focus will shift towards, for example, system level design and detail design more. The focus needs to be shifted in specification or planning or making. So, and that's what we're going to talk about in this lecture. There are 9 different categories of product types that affects the process that we're going to talk about. Could be more, could be less. This is just one definition and one way of categorizing the differences. We are starting with market pull products. This process and this type of product start with identifying a market opportunity. There's already a demand, and the goal is to find the right technology to meet that customer need and that demand. The development process follows this, structured path: planning, concept development, system level design, detail design, testing, refinement, and finally product ramp up. This is the same as the generic process, product development process, or that generic mechanical design process. A great example of this is sporting goods, furniture, tools. Companies see a demand for a better baseball bat, for example, a more ergonomic office chair, or a more durable wrench, and then work to develop the technology that kind of meets that demand and that need. So the market is kind of driving this, the need from the market, and that's what the name market pull comes from. Second class of products that affects their process is technology push products. This is kind of an opposite approach of the first one. Here, the team starts with a new technology. So the technology already exists, and the team looks for a market for it, a demand for it. The first step, there was a demand, and the team looks to find a proper technology for it. In this case, the technology already exists, but they're trying to find maybe a different market for it. The planning phase in this case and this process is about finding the best product application. While, concept development starts with a already defined technology. Good example is, think about Tyvek envelopes or Gore-Tex rainwear. Both started as advanced materials. The technology already existed for some other applications, but then the company figured out that they can use this technology and in different products for different applications. Next one is platform products. These type of products are built on a pre-existing technology platform, meaning the core subsystem already exists. And the development process focuses on how to build on top of that core system that already exists. The concept development stage works under the assumption that this platform is reliable and proven and has its own customer base. A perfect example of it would be consumer electronics, computers, printers, gaming consoles. Many new smartphones or gaming system are built around an established hardware, software, and then we make improvement in the software, they make improvement in the design. So they're kind of building upon an existing technology. Oftentimes, platform product also refers to the product that they all kind of interconnect with each other based on an existing technology. For example, again, gaming consoles are a good example of it. There are variety of products that they all work with each other to kind of make that gaming console, and you can buy accessories, buy add-ons, and all of that. They're all working on the same platform. The next one we're talking about is process-intensive products. Here, the product characteristics are heavily influenced by manufacturing process. So either an existing production process must be used for the start, or both the product and the process to make that product needs to be designed and evolved and built together. And that's the distinguishing feature about this process is a good example of this would be snack foods, cereals, chemicals, semiconductors, stuff like that. The way these products are made defines their characteristics, and manufacturers work within those constraints to develop new products. So next one we're talking about is customized products. These products are slight variations of existing configurations. They're not built from scratch, but modified version of an established design or an older design. Because of this similarity, the development process is highly structured and efficient because it already exists. They've already developed some similar products. Common examples are engines, switches, batteries, containers, where companies just tweak an existing design to upgrade it to meet maybe new customer needs or specific customer needs. So that's where the customization come from. They're often tweaked to meet a specific customer market or customer needs. Next is high-risk products. These are products that face a high risk of failure due to technical or maybe market uncertainties. Risk and certainty always go hand in hand, and that's why uncertainty in the existing technology or the market creates that higher risk of failure. There's either a challenge in the marketing of the product or uncertainty about whether even it will work, or even it will succeed in the market that is being designed for. To manage this, risks are identified early on, and rigorous testing happens throughout the process to make sure everything is on track. Good examples of this are pharmaceutical medications, drugs. A good kind of a recent example is a COVID vaccine. When the companies were working on it, they had no idea how the market would react to it, but in addition, they didn't know if this is going to be effective or work for the design vaccines. Developing a new drug or spacecraft, anything like that involves significant investment, and they often require a long period of validation and testing to kind of reduce the risks. Next category is quick build products. These products rely on rapid prototyping and iterative design cycles, where products go through multiple design, build, test phase until they're ready to be, for production ramp up and a scale up. Because of this, detailed design and testing are repeated several times throughout the process. Good example of this is software and cellular phones, where new versions are constantly tested, updated, and improved before launch. And again, depends on type of product. But for example, softwares, a lot of large software companies such as Microsoft, Apple, a lot of big app developers, they have a cycle of a new version of software every day. At the end of the day, a new version is updated within the company and modified. So the next day they start with a new version and they start kind of testing and adding on. So depends on the product. There could be a lot of these quick build cycles. This type of process is also referred to as a spiral product development process. Next, we have product service systems. This category includes products that are developed alongside their service element, meaning both the physical and operational aspect of the design are done together. The key is to create a smooth customer experience and efficient process flow. Good example of this is software applications, financial services, restaurants with their digital ordering and tracking systems. Think about how a restaurant might design both its kitchen layout and ordering app at the same time to work seamlessly together, and they're developed together at the same time. And then finally, the last type of product that we will talk about is complex systems. These type of products are highly sophisticated and consist of multiple subsystems and components. They require multiple teams to work on parallel before integrating everything together. The process involves decomposing the system into manageable parts and smaller parts, developing them separately, and then bringing everything together for system integration and validation. Good example of this would be, complex system, jet engines, automobiles, airplanes, aircraft, stuff like that, where a lot of different teams work on the engine, for example, electronics, materials, aerodynamics, before everything comes together and then assemble together in final parts. So kind of going back to that first slide that we had, the first box here up here, again, that's the generic product development process or mechanical design process. Phase 1, phase 2, this is phase 3, and this is phase 4 of the project that we always talk about. But when you look at, for example, 2 other variations that we have plotted here, put it on diagram. For example, quick build product. Remember, there was a lot of iterations of quick design, build, test cycles. So when you get to the detailed design phase of the project, so again, we still have phase 1, phase 2, phase 3, and then kind of a little bit has even tapped into phase 4 a little bit of the project. When you look at complex system, that was the last slide that we talked about, that detailed design includes multiple teams that are working parallel together. So when you look at these 2, quick build products and complex system, you see the difference. The difference is there's a lot of cycles, maybe one team, maybe a couple of teams are working on that cycle, but it's a lot of back and forth. So you design, build, test, go back, design, build, test, and so on. Versus in complex system, parallel teams are working together towards kind of designing, testing, building their subsystem that they are responsible for. Thank you very much.